All right, this is slide 12, just looking at acid strength and equilibrium position. So there's a little bit of notes, and then we'll do a couple sample problems on how to solve for these. Okay, so an acid is described as weak if its characteristic properties are less than those of a common strong acid, such as hydrochloric acid. So really, and we talked about what makes acids strong or weak in the last video, so just check those out. Okay, so weaker acids or weak acids are weaker electrolytes and react at a slower rate than strong acids do. So the pH of a weak acid is going to be closer to 7 than the pH of a strong acid, which is usually around 1 or 2. So acidic acid is an example of a weak acid. It reacts only 1.3% in a solution at 25 degrees Celsius and a concentration of 0.1 moles per liter. So really what we have here for our equation, so we have acidic acid when put in a solution with water, only 1.3% of it actually forms this hydroxide, or hydronium, sorry. Okay, and then its conjugate base. So the hydronium ion concentration of any acid solution can be multiplied by multiplying the percent of the reaction by the initial amount concentration of the acid in the solute. And so in this case, like for any strong acid, it goes like 100% here. Okay, so the equation would just be like to find the concentration, it's 100 over 100, because that's what percent times the initial concentration. Okay, so 6 strong acids, okay, will always be 100 over 100. Like whatever the initial concentration, it is what the final concentration is. Okay, but for weak acids, we have to follow this this is our formula that we'll use. So percent ionization is equal to, and this works for weak bases too, but percent ionization is equal to the concentration of hydronium over the concentration of our initial concentration of our weak acid times 100%. So if we want to find our hydronium concentration, it would be our percent, so like in this case 1.3 over 100 times our initial concentration. So like if we were finding for this one here, which we have to do here, so I'll do it down there, and so that just shows you what those mean. Okay, so like a sample problem here. Okay, so we have a 0.1 mole per liter solution of acidic acid. Only 1.3 goes to produce our products, and they've reacted at equilibrium to form hydronium ions. Calculate the hydronium amount concentration. Okay, and so we're going to use the formula from up here, or like this formula here. Okay, so hydronium ion concentration is equal to our percent, so 1.3 divided by 100, okay, times our initial concentration, 0.10 moles per liter. So our hydronium ion concentration is equal to 0.0013 moles per liter. Again, this works for acids. This would be the concentration of hydroxide, and this would be your initial concentration of your weak base. So either way. Okay, the pH of 0.1 mole per liter methanoic acid is 2.38. Calculate the percent reaction for ionized methanoic acid. Okay, and so start by writing our balanced equation. That's what we should always do. I didn't do it for this one because we already had it up earlier in our notes. Okay, so here's our balanced ionization equation. Okay, we know that, or we were trying to find this percentage here. That's our unknown. Okay, we're given, okay, the pH. So remember, the pH helps us solve for the hydronium concentration. So the hydronium concentration is equal to 10 to the negative pH. Okay, which we actually talk about these, how to use these more in the next video. So you can, if you forget kind of how to do it, move forward and watch that video. But so 10 to the negative 2.38 will give us a hydronium concentration. 0.00417, we'll call it there, moles per liter. Okay, we're also given our initial concentration. This concentration here is 0.10 moles per liter. So this is the formula we'll use, which we learned up earlier on the page. Okay, so we just put our numbers in. Okay, so here we go. Our units cancel off and we're left with a percentage. And we should get 4 point, and now we look for significant digits. Okay, this is to remember for pHs, we only count those after the decimal place. Okay, and then this is also to, so we're going to go 4.2%. Okay, would be our answer. Okay, and just another learning tip here for aqueous solutions of an acid, percent reaction with the acid with water is also commonly called its percent ionization in chemistry references, because the net effect of the same is the same as if an acid molecule simply ionizes, okay, as it was once simplistically assumed in Arrhenius's original theory. You should consider reaction with water and ionization with water to be equivalent terms for any of this acid-base solution theory. Again, you may expect to see either used in the text or in any question on your workbook or quiz or test.